Hello and welcome to another one of my tutorials. This tutorial shall be based on my previous two GPIO videos. There are links to them in the description below. At the end of this tutorial you'll be able to read an input from button and make it display a message on the screen. Again, in this video we'll be using Python, as this is the best beginner's language. All code and necessary information will be in the description below. Equipment that you will need: a Raspberry Pi with the rpi.gpio module installed. If you do not have the module installed and working, please view my previous tutorials using the GPIO Part 1 and Part 2. These will guide you through how to get it working. A breadboard, also explained in my previous video. 3 male to female jumper wires to connect to the Raspberry Pi's GPIO pins, as they're all male. A momentary push button, which I'll explain later, just the differences between a tactile push button and a momentary one, which momentary is the one that you'll need. And you'll also need a 10 kiloohm resistor. Now to wire up our circuit, but first I'll explain why we need a momentary push button and a 10 kiloohm resistor. We need a momentary push button instead of a tactile switch, because a momentary button is only on for as long as you press it on. So if I just did this, it's gone for only the time that I was holding it down. That'd be on, that's off. A tactile switch remembers its last state, so if I just did, that'd be on, and if I clicked it again, it'd be off. An example of a tactile switch would be a light switch, but you could modify this tutorial to have a tactile switch, but just for my use I'll have a momentary push button. Push buttons normally come with 4 legs. They're set up into pairs. If you have one with 4 legs, then all you need to worry about are the 2 or one set of them. So this 2 or that 2, doesn't really matter. If your push button has only 2 legs, well, that's great. You don't even have to decide which pair you want to use. So let's put this in the breadboard. Just make sure that all of the different legs are in different rows. Otherwise, if they are in the same rows, then things won't work out just how you wanted them to. So the good thing about breadboard is this gap, which you can utilise so all of the legs are in separate rows. So if you just push it in firmly, as you can see, it's in nicely. Now, as I said before, we need a 10 kiloohm resistor. You may be wondering why we need a resistor. Well, basically, this resistor is going to go straight to plus 3.3 volts. And you could make this circuit without a resistor that goes to 3.3 volts, but you get what's called a floating point button. And basically this means that the button doesn't know whether it's on and off. So when the button's not being pressed, it might think that it's on, or even when you press it, it might think that it's off or hasn't even been pressed, or those things. Basically the button gets really confused. So this just pulls it up to 3.3 volts if you haven't touched the button, and if you have touched the button, it just pulls the circuit down to 0 volts. So this way our Python program can determine whether the button has been pressed on or off. Now, how are we going to attach this to the breadboard? As you can see, these 2 legs, which are the ones that I'm going to use, insert this into one row in which the legs are in one of the legs, and just connect it to a different row. In my case it's going to be the vertical ones, because that's really the ones you should be connecting to, just to keep so everybody knows what your circuit looks like. And down this there'll be 3.3 volts running. So yep, that's your button and your resistor wired up. Now we're going to need to wire it up to the Pi. So you have your 3 male to female GPIO jumper wires, just so we can connect to the Pi's pins, because they're all male. And so if you just have some male to male jumper wires, they won't work. You need female to male ones specifically. Let's just connect it to ground. Now, as I showed last time, ground is just 3 pins down from the right. Again, I can't stress enough how much care you need to take when when working around the GPIO pins, they're not protected, so if you wired up something wrong, then most likely you will blow up your Raspberry Pi, and any damage will be permanent. It's nothing to do with bricking the SD. Now just connect it to this, the other pin, not the one with the resistor on, just the other pin, like that. And so let's just search for Raspberry Pi GPIO pin layout, just so we can see what one we're going to need to connect it to. Now, you can get a diagram of the Raspberry Pi's GPIO pins just by Google imaging Raspberry Pi GPIO layout. Now, here we go. Here we are. We're going to be using GPIO pin 17 for this one, and as you can see, it's 1, 2, 3, 4, 5, 6 down on the left. It's actually pin 11, but because of that, the Broadcom calls it, the Broadcom is the central processor, I mean, the Broadcom calls it GPIO 17, so we're going to have to write the program to recognise it as GPIO 17. So now that we know it's 6 down, let's just connect it. Here we are. Now, we're going to connect it to the same pin that the same pin on the button that the resistor is on, like this. So, you get your second male to female jumper wire, and count down 6, 1, 2, 3, 4, 5, 6, and just connect it. Take great care again and then just connect it here. So I just try to show this a little bit clearer. At the moment, your circuit should look like this, with this going to ground, this going to the GPIO 17, and then the resistor, which are just about to wire up to plus 3.3 volts. Now if you look at the screen again, plus 3.3 volts is pin 1, so that's easy. We just connect that to pin 1. Here we are. Now using your third and final GPIO wire, simply connect pin 1 to the same row that the resistor is in. Now, I'd recommend doing this when the Raspberry Pi isn't on, just in case you wire up wrong. And so once you've finished wiring it up, just check to make sure that your circuit looks sound, and then we can start coding it. So now that your circuit is wired up correctly, start up your Raspberry Pi, log in and load up the desktop environment with the command startx. Once into the desktop, load up idle 2.6.6 Python environment, either by here or just through the start menu. Now, I've already made my program, I've already typed it in just to save us a bit of time, but all of the code and any commands that I use in this tutorial will be available in the description below, just so you can easily copy and paste it in. Now, run through the program. Import rpi.gpio as GPIO. This basically is telling the Python to import the module which will allow it to access the GPIO pins on our Raspberry Pi. If you haven't installed anything by the name of rpi.gpio, then this program probably won't work for you. I suggest you watch my previous programs in which I show you how to install the module. Now, next part. Set up pin 17 as an input. GPIO.setMode, GPIO.bcm, GPIO.setup, 17, GPIO in. This just allows us to activate pin 17. Now, next part. This is sort of the main body of our program. While true. This is just a while loop. While true means that it will just do this forever and ever unless you stop it. Now, here's a variable. Input value is equal to GPIO.input17. This is just telling us whatever happens at pin 17 with nicknamed input value. Okay, next part. This is an if statement. If input value is equal to false, print the button has been pressed. Basically, the if input value equals to false line, that just translates into if the button has been pressed, do this command. Now this part's also important. While input value equals to false, input value equals GPIO.input17. If you don't have that part of your program, then when you let go of the button, it's going to think that you're still holding it on. So this is called an embedded loop. So that part's incredibly important. Otherwise, it's probably one of the most important parts of your program. Otherwise, if you don't have that, then it's not going to work. Now, once you've finished that, just save it into whatever file you want. Make sure you add .py onto the end, and then open up a terminal. So, probably get something similar to this. Now we're going to have to navigate to where our file is saved. In Windows, files are saved into folders. In Linux, files are saved in directories. Now, you change directory simply by doing the command cd. So cd, because I'm using just the default user with the Raspberry and distro, mine's probably going to be something like this: home/pi/wherever you've saved it. In my case, I've made a new folder and saved all my projects into mtb, then another /. If you press enter, you'll see that I've changed the directory to mtb, which is just as we want it to. Now we're actually going to try and run the program. We're going to need to do sudo, minus capital letters of course, sudo, which just means that I'll be the super user. I have super user privileges and I can do whatever I like basically. Python, then the name of your program. Make sure, again, I can't stress enough that you need to put .py onto the end of your program. In my case, my program is just simply called button.py. Press enter. At the start, you probably won't see anything. However, if we go down to our button and we click it, we'll see that we get a little message saying the button has been pressed, smiley face. Click it again and again and again and again. We see that's just continually printed out. Once you've had enough of that, simply press Control-C, which is the default way of ending a program in Linux. Probably get something like that, just an annoying message saying that I've had a keyboard interrupt. So, maybe a challenge for you is to integrate this program with the previous program that you've done using LEDs. Maybe when you click the button, a pattern of LEDs flashes out, say 5 LEDs. That's just a challenge for you there. I hope you've enjoyed this tutorial. Please subscribe and tell all your friends about my videos. If I haven't been clear enough, or there's anything that you're stuck on, or this tutorial didn't make sense in any places, just simply comment below with any queries that you have, or email me at the raspberrypiguy@gmail.com. I'll try to get back to you as soon as possible. Also, if you have any suggestions or any projects that you'd like to see me do, don't hesitate to email me or comment on me. Thanks for watching, and hopefully I'll be making a new video soon.